Hey guys, gonna do lesson 3B5 before I leave work here today. Shut the camera. Hey guys, gonna do lesson 3B5 before I leave work here today. Our learning target this time is that we can use intercept form to graph a quadratic function. Intercept form of the equation looks like this. We have our f of x or our y equals a, and that a value is going to be the same as it is in standard form, and then x minus p times x minus q, and I'll show you what that p and q are in just a minute. So this is basically just another way to graph quadratics. Intercept form of a quadratic is simply its factored form. So I went ahead and typed that in for you. So if I want to take this equation that's written in standard form and write it in factored form or in intercept form, then all I need to do is factor it. So remember to factor. I just have an a is equal to 1 here. So I am going to find my factors of 8, and I want something that adds up to -6. My multiplication here multiplies to be a positive, but my addition is negative, so both of my factors should be negative. The first thing that comes to mind is -2 times -4, which does add up to -6. So that means that my factored form of this equation is f of x equals x minus 2 times x minus 4. Okay, so let's go ahead and see how we can use that, which is now written in intercept form, to graph our equation. So our general rules, and you'll want to pause and get this information written down, but we're going to first identify the x-intercepts and plot them. The reason we call this intercept form is because by looking at it in factored form, you can find those x-intercepts. Whatever your p-value is here is going to be the x-coordinate of your first intercept, and whatever this q value is the x-coordinate of your second intercept. So let's go ahead and do that part right here. I've typed up the equation that we just came up with. Our x-intercepts then, this is my p, and this is q. So my first x-intercept is at 2, 0, and my second intercept is at 4, 0. Notice I didn't pull that negative because that's a part of the formula. So I'm just looking at what value is right here. So I'm going to go ahead and plot those points. Let's pick a different color. And 2, 0 is right here. I went over 2 and not up or down at all. 4, 0 is right here. So those are my x-intercepts. Okay, my vertex, so the next step is to find the vertex and the axis of symmetry. The x-coordinate of the vertex is going to be, I'm going to write it over here, is going to be p plus q divided by 2. And we put a little note here to think about it. It's halfway between the zeros. So you're adding p and q and dividing by 2. You're finding their average, which is something you probably learned in a previous class. So for the vertex of this one, I'm saying 2 plus 4 and dividing by 2. So that ends up being 6 over 2, which is 3. So the x-coordinate of my vertex is 3. And then I'm going to plug that x-coordinate into my equation in order to find the y-coordinate. So I'm going to come over here to some scratch work area. And in place of that x, I'm going to put 3. So f of 3, because we just found that that was the x-coordinate, is going to be 3 minus 2 times 3 minus 4. So I just replaced all the x's with 3's. 3 minus 2 is 1, and 3 minus 4 is -1. So that means that the y-coordinate of my vertex is -1, because 1 times -1 is -1. So my vertex is at the point 3, -1. So I'm going to go over 3, which is halfway between those two, and down 1. And there's my vertex. The axis of symmetry is going to have that same formula. It's going to be p plus q over 2. Except here, I just need that x value. So my axis of symmetry is going to be x equals 3. Remember, that's just this line right here that goes through my vertex and gives me a reflection point. Okay, the next thing I want to do is find the y-intercept. And once I find the y-intercept, I reflect it over that axis of symmetry. To find the y-intercept, I'm going to calculate f of 0 because that's the point where my x value is 0. So I'm going to go f of 0 equals, and in place of all my x's, I'm putting 0, so -2 and 0 minus 4. 0 minus 2 is negative 2, and 0 minus 4 is negative 4. So that means 8 is my y-intercept. So my y-intercept is the point 0, 8, which means I don't go side to side at all, but I go up 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to reflect that to get myself another point. So it's 3 away, so I'm going to go 3 away here. Okay, it says find 1 or 2 other points if needed. I don't think I need it here. I think I can see the shape of this line. And so I'm going to sketch the curve. Y'all bear with me as I draw my ugly parabola. Oh, that wasn't, oh, I spoke too soon. Okay, so there's my parabola. All right, let's go ahead and do another example. I've put your intercepts here for you. So the first thing I'm going to do is try and factor this. I'm going to pull out a greatest common factor of 2 here, which leaves me with x squared plus 3x minus 4. I just divided each term by 2. And now when I factor this, I'm going to use some scratch paper down here. Scratch computer. I want factors of negative 4 that add up to 3. So factors of negative 4, maybe negative 1 and 4. Negative 1 plus 4 does equal 3. You'll find that you get better at picking those numbers as we go on. Hopefully you're already pretty good at it. Okay, so that means writing this in intercept form, I've got 2, and then I've got x minus 1 times x plus 4. So that means that my x-intercepts, this one is positive 1 when I write it as an intercept. It's going to be 1, 0. This one, let me go off to the side for a second. Remember that our formula had a minus right there. Because this has a plus, we have to think of it as minus a negative 4, because remember, that is equal to the same thing. So that means my value that I'm pulling is negative 4 when I see that plus sign. So my intercept is negative 4, 0. Okay, so when I plot those, I go over 1 and not up at all. And then I go negative 4, so 1, 2, 3, 4, and not up at all. Okay, for my vertex, I'm going to say P plus Q, so 1 plus negative 4 divided by 2, because remember, I'm just going to rewrite this for us. X minus P times x minus q. Okay, so 1 plus negative 4, because 1 and negative 4 gives me negative 3 over 2. And that is, what happened? That is going to be a decimal, but that's okay. That's negative 1.5. So I'm going to go negative 1 and then 0.5 is where that axis of symmetry is going to go. Okay, should go down here as well. So my axis of symmetry is x equals negative 1.5 or negative 3/2, whichever you prefer. My vertex, though, I know it's got an x value of negative 1.5, but I've got to figure out the y value by plugging it in. So my formula is 2 times x minus 1 times x plus 4. I am replacing all of my x's with negative 3/2. So it's going to be f of negative 1.5 or 3/2 equals 2 times negative 1.5 minus 1 times negative 1.5 plus 4. Okay, so I'm going to do what's in my parentheses first. Negative 1.5 minus 1 is negative 2.5. Negative 1.5 plus 4 is going to be 2.5. And then I'm going to multiply all of this together, and I'm going to do that in my calculator. Times 2.5 times 2, and it is going to be negative 12.5. So my vertex then is negative 1.5, and then I'm going down 12.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh no! 12.5. How did we pick an example that did that? Okay, and then my y-intercept, I'm going to do 0. So I quit scrolling here. So I'm going to plug in f of 0, and that's going to be 2 times 0 minus 1 times 0 plus 4. And we get 2 times negative 1 times positive 4, which is negative 8. So 0 and negative 8 is 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to reflect that. So it goes right here. So my y-intercept is 0, negative 8. And then I'm going to sketch this curve. Okay, if you want to get some extra points, you can. Usually 5 points is enough, though. So there we go. Okay. There is not an application for this lesson. Go ahead and do some practice. Let us know if you need help.